Hey, so I just wanted to record a quick intro video. If you just joined our recent class and you watched me go over some Python in the pre-work day one, we talk about reading, writing files, reading a directory of files. Let me click on things. Yeah, there we go. Anyway, reading CSV files and extracting text from a PDF in Python. We also talked about setting up Ooga Booga with Google Colab. Ooba Booga. Yeah, there we go. Isn't it a silly name? Anyway, okay, so we go in here, colab.research.google.com, and that's all you have to do is just go to this browser tab, right? And it will open one. It'll give you an open notebook thing. You can click new notebook, and that's what you'll get is this here, right? This is the welcome to Colab. I can click new notebook, right? And so it says start coding or generate with AI. I don't know if I have a pro subscription, but we'll see. Yeah, it's a limited time available for unsubscribed users, but later it'll be available only to pro users. This is code. This is Python. That's what you're dealing with right here. You're dealing with Python, but you're dealing with it using a really big thing, a really big computer, so that you can run like AI models on it, right? And so when you're in here and you click connect, and then you click like connect to a hosted runtime or change runtime type or whatever, you just kind of click play, you're going to get a computer basically that the Google is running, and so you can execute code on it. You're really just getting like a computer that no one is using right now. So you could have it shut down at any moment, but it's free. So like you get what you pay for, right? So this is a little bit like Replit. If you've ever used Replit, replit.com, you can log in with, if you have a user. Hold on, let me do this. And so, you type in your password and you log in. And so if you've ever created a REPL and clicked Python, it's the same thing here. If I were to say like new AI project, it's my AI project. I'm going to give it a creative name if I'm going to come at it with intention, but this is an example, right? And so this is a code environment. Again, another computer is running this code somewhere. It's set up to run Python so that you don't have to worry about install and stuff like that. And so that's what's also going on here. The thing that's nice about these things is that, one, Google gives us a really beefy computer to run our AI stuff on. And the other thing is, you have all these little individual cells that you can kind of run one at a time. And they all share the same memory. So you can set up some variables in one area and then use them later somewhere else. It's just really handy while you're like developing and making something. It's a really good tool system that a lot of developers really like for when they're sort of, just figuring something out for the first time and trying to figure out how it will go, and like writing a whole bunch of little parts and somehow figuring out how they're connected, but without having to think about it a lot. So it's a tool that's pretty good for thinking and coding, and that's why we use it. And it'll run the things we want. You're going to find a lot of Google Colab notebooks in the field of generative AI. This is the general way that people tend to communicate with each other, not through GitHub repos, but with these notebooks. These notebooks come with a whole bunch of stuff like change tracking, right? And so we have revision history. We just don't have merging and things like that very much. You can track these in GitHub. So if you're an experienced developer, you can connect it right to GitHub and it's easy. But if you're not, don't worry about all that. We're just going to give you code and you're going to be able to run it. What we want you to be able to do is start to get curious about the code you're running and read through it if you're not experienced with Python, right? So I'm going to just go over a little tiny bit of Python and how I want you to interact with the documentation, right? So if we go in here to Obsidian Publish and we are in our multiverse school curriculum. We go in here into, let's see, under autonomous agents, and it's under prompt engineering, and then we go into the syllabus, and the syllabus, or sorry, the pre-work has some links. Reading and writing files in Python, reading a directory of files, CSV files, and extracting text from a PDF, right? So let's look at reading and writing files in Python. A lot of times what you want to do is figure out how to do a task at this level. I want to like have the AI do something, but then I want it to be in a file, right? In like a file where I can like edit it, really, in like an editor that I like to use, maybe something like Obsidian, right? This is how we do that, right? But this is only the code that we need to write to a file. It's not the code that we need to like actually talk to the AI. So a lot of what code is sort of assembling a bunch of things together, right? That you know how to do, like open a file for reading in Python, and get them to do them in order. Kind of like a macro. If you've ever made like a macro, or you've ever recorded something that you did on your computer and then it like does it or something like that. That's really what we're doing, right? Or like Zapier, right? It's just that we do it with text instead of with Zapier. That's really the main thing. So how do we do it? How do we actually like make an we gotta write code to do what? Well, that's the thing that we want to understand how to do first, before we go trying to write code, right? Like nobody sits down and writes code. Most of the time they start with sort of some notes, right? So something that I can do is I can actually click text here, and I can have like a little text notepad. So I'm going to make myself a plan for what I want to do, right? And if you ever need help kind of with that process, in here in the algorithm section, like again, you have access to the whole curriculum. Here's the Introduction to Problem Solving for New Coders class. It has a whole bunch of stuff and videos, so like walk through that if you're interested in really doing a deep dive. But right now, let's stick with our high level stuff. So I'm going to look at, go back here to pre-work day 1, and I'll look actually at the prompt engineering syllabus, and I'm going to look at some of this stuff like develop a complex prompt and rubric for artifacts you commonly produce with AI, and develop a benchmark to test a prompt or a prompt template. Okay, so that's really, really high level, super high level. So what is it that we really, really want to do? Well, we want to, given a series of prompts that I want to run each prompt separately, pretend I can spell, as a new conversation, right? Get the results, write them to a file. Cool. That's all we really want to do when we have a benchmark, right? A benchmark is just a big automated suite of tests, right? A big set of prompts that we give to an AI to test whether or not that AI knows how to do kind of general stuff, right? And so you can have a whole bunch of prompts that just things that you want the AI to be able to do, right? Like maybe you want to write a poem writing AI. And so you want to write a good prompt that gives it enough information to write a good poem, or gives it a few automated like reference people so that it doesn't write a generic poem but brings in a few influences, right? So like that's an interesting bot. So maybe you'd have a few prompts for a poem. I want a haiku. I want a medium length poem on the nature of being. I want a medium length poem on snakes. I want I want a haiku about how the seasons are like the seasons of technology. Some basic like prompts that you might want to run over and over again And then so you have prompts, and then you have a system prompt, right? So now that I'm thinking about it, and I have this list here, I want to say, give a system prompt. And then, like, really what I'm thinking about is I want to test which system prompts produce the best outputs, right? Given some task definitions. So maybe instead of a series of prompts, because that word doesn't tell me, and this list is for me to understand, series of prompts that I want to run. I really want to do task definitions that I want to run. Run each task definition. That's my tummy. Separately. Sorry, each task definition with the system prompt separately as a new conversation. Get the results and write them to a file. So I want to be able to give a system prompt, but I also want to maybe be able to, given a list of system prompts, so like I want to have, you know, maybe I could just say I want to have a list of system prompts, and then I want to have, like, I want a function that, given a system prompt, and now I'm starting to, like, think in terms of a chunk of things, right? I've got, like, this system prompt and the task definitions, and I've got run each task definition with the system prompt separately as a new conversation. This might help if I sort of say, like, you know, given a series of task definitions, I'll sort of tab this over because this is sort of inside of these things, right? And then this is really inside of a function that takes a system prompt and the series of task definitions, right? And then so these are all, like, this function gets run for each system prompt, so I can just sort of say for each system prompt, and then I want a function, well, run a function. That's really what I want to do there. I want to run this function, you know, and then that, given a system prompt and given a series of task definitions I want to run, for each task definition, run each task definition, or query the specified language model with each task definition with the system prompt separately as a new conversation. Okay, so query the specified language model. So then I have to say, given a specified language model, and so I probably want to test multiple language models. So I want to test multiple language models. I want to have a list of system prompts, right? And so this is what a benchmark does. We have some language models. We have a bunch of system prompts, a bunch of sort of characters, personas, contexts, and definitions that we give it, right? Like, write a poem that is dramatic and bold, but engaging and nuanced. Write a poem as if you were really heavily influenced by William Henry Wordsworth and Maya Angelou's poetry. You know, you just pick some things that are system prompts, right? And you sort of have also a bunch of, like, so you say that you're a poetry writing robot, bring in these influences. You love these authors, right? You could have a bunch of different system prompts that you try. And then you have multiple language models. Ask ChatGPT, Claude, Llama 2, Mistral. And then we have task definitions, right? Write a poem about snakes, write a medium-length poem about snakes, write a haiku about snakes, write a haiku about how snakes are an allegory for life, write a haiku about how snakes are an allegory for death, write a haiku about how snakes are an allegory for wealth, and so, like, you could have a number of task definitions like that. That's what I mean. So in the end, we have something like, you love Emily Dickinson and William Henry Wordsworth and E.E. Cummings. And you are going to bring in those influences as you conceptualize of your next poem. And that could be the system prompt that you're trying, and you're getting that to ChatGPT. And so that's the specified model. And then you have the task definition. Please write a haiku about how snakes are an allegory for life, right? And now you can change any one of these things, but you don't want to do the changing. You want to use a for loop to do all of the changing. You want to run them all. Gotta run them all. But it costs a lot of tokens to run them all, right? These task definitions have to be well chosen to show off the broad range, right? You don't want to have it generate 40,000 poems, all of them at least 3 stanzas long, like in a minimum of 700 tokens, right? Because that would be a lot of tokens, probably cost a lot of money if you want to use every poet crossed with every other poet, crossed with every other, like, animal as every symbol, right? You wouldn't want to run that many things. You want to just have a small subset that sort of shows off a whole bunch of different possible things that it could do. That's what a good benchmark contains. So that's what we're going to build out. We're going to write Python that will do each one of these things, right? So how does it relate? I've gone on for several minutes here. How come we haven't written any Python? I thought this video was about writing Python. You started talking about Python, then you just talked for like a long time and wrote like a whole bunch of stuff. That's because this is the understand, match, plan, implement, review, evaluate, the umpire process. And this is what it is to be a coder. So we have spent most of our time on the understanding phase, and we have matched what we know in the back. We've sort of talked a lot about prompt engineering and how you might do some of these things. So we matched sort of our domain knowledge, right? That's what you saw me do there. And then we made a plan. That's what this is. Each line here is just a little individual Python problem that I have to solve. Instead of me having to write and think in code, because Python is not my native language, right? Like, I grew up speaking English, not Python. So I think in English. I speak in English all day. I'm talking in English right now, a natural language. I'm not talking in Python. So I have to translate every line. So this is how we do that. We start by understanding. Now we can look at our toolbox, right? Let's look at pre-work day 1. What's in our toolbox? Reading and writing files in Python, reading a directory of files, reading CSV files, extract text from a PDF. Okay, cool. So let's look here. What do I have to do here? So I want to test which system prompts produce the best outputs, given some task definitions. Okay, it's a high level what I want. That's not like a line of Python I'm going to do. I want to test multiple language models. I want to have a list of system prompts. And then I want to have a list of task definitions. I want to have a list of task definitions, right? So what does a language model really look like? Well, if we kind of go back to the code that we wrote, I think it was maybe on my computer. If we kind of think back to the code that's at OpenAI, if we go open begin, right, and we go back into the platform, and it's like makes you log in. we go to the playground and we click chat. We click view code, right? And we gotta go Python. Okay. So now we kind of look here. This is that code that we were going to use. This is how we go talk to the AI. So this is sort of like the end thing that we want. So we have to figure out how to get all the pieces for this into it, right? So I'm going to copy and paste it. That's a good way to do it. No reason not to. I can just sort of put it down here. I can go code. Nope, it doesn't want me to do that. Oh no, it does. It's cool. Python. Great. Now it knows that it's Python. So we import OpenAI. We do all that stuff, so I'm not going to worry about that. There's no code or anything, but there is a model. And what is this? Well, it's a string. So this is really what I want, a list of language models, right? So I can say I want to test multiple models. I need models equals, and then it's Python, and it's a string. There we go. So right now we'll just say that we're testing GPT 3.5 Turbo, and that's it. Later we can add in more language models, right? So I want to have a list of system prompts. Okay, system prompts, right, equals, and we'll just say, okay, you are a poem writing agent. Please write a nice poem. Great, period. That's the only, and so this is sort of the start with one strategy, right? When I add these braces, I'm saying I want to have multiple things. So this could be, GPT-4 could also be in here, right? So this is a list, and I I know that it's going to be a list because it's multiple. So we want something that can do multiple. And so I did multiple, but here I said a list. And so I just even used the word a list, and that's what this is called, a list. And so then I want to have a list of task definitions. Okay, task definitions, and then you make one. So this is prompt engineering. Start with one, and then add more to the list. This is another way that I can do this. I can sort of say hey, maybe they're going to be a little long. I want one per line, right? And so I can do it like this as well, right? And I can say, please write a poem about snakes. Please write a H-I-K-A-U. I could have looked this up. H-I-K-I-U. No. H-A-I-K-U. Thanks. Okay, great. Good thing I can Google things. H-A-I-K-U. About snakes. Please write a haiku about using snakes as a metaphor for life. And then we'll do for death, just to make sure it can do sort of opposites, right? And this is often how you start a benchmark, is just with start with a thing, and then you're get more specific, do an opposition, and you just sort of start with that. And then you have a lot of ideas about what you could try out, or you can actually brainstorm with ChatGPT. But starting with this is generally what we want to do, right? And then so for each system prompt, how do we do that? Well, for system prompt in system prompts, ta-da, for loop. And then we want to run a function that, given a system prompt, given a specified language model, given a series of task definitions that I want to run. Okay, so I'm going to have a for system prompt and system prompts. I can do, maybe I want to do for language model in models, right? And I can sort of tab everything over. For each model we're testing. And this is how we code. It's not just type the code out top to bottom, right? It's we do one little piece at a time, and then we okay, so it's, you know, and then there's for task in task definitions, right? Okay, cool. And then we can just call a function that doesn't exist yet, right? Prompt language model system prompt task definition, and then it's like results equals, and then we want to save to file language model system prompt and task definition and results. Cool. Okay, so that's, you know, run a function that, given a system prompt, given a specified language model, okay, that first, given a series of task definitions, and I'm using Alt up and down to move things around. And then we get the results, and then it says for each task definition here. Okay, so, you know, I'm just going to move this in here. Yeah, for each task definition. So that's where that was sort of documented. And then what else do we have? Yeah. And then get the results, write them to a file. Cool. So I'll just tab this over. I'll tab all these over. There we go. Cool. Now you can kind of think of these as like in there. And this query the thing, query the specified language model with each task definition with the system prompt separately as a new conversation. Great, done. So we've got the things written, and now I'll go ahead and I'll just move this little Python thing up because we've actually changed our text into Python. This whole time we were writing Python. Oh my gosh. We just haven't defined these functions yet. Prompt, save to file. But here's basically what goes into prompt, right? So now I just need to say def prompt. And we're going to take a language model, system prompt, pt, task definition, right? We'll do this outside of the function so that we only do it one time at the start. And then we go and we get the response, right? We're still using that code that we've copied and pasted, but model needs to be this variable here. Boop. And then the system prompt and the task definition are like, you are a poem writing robot. Please write this thing. So we'll say, I'm going to call this, let's see, there's something about the system prompt. I'm going to go back over here and just show you like, hi. Okay, and then we'll click view code, and you can see it comes in here, messages, role, system, content, hi. Okay, so we want that. Let's go back to our code. We'll do this. Oh no, that's not it. Hold on, if that happens where you can't edit it, you just click this. Okay. And then you do this and paste this in, fix the indentation so you can read it. And then instead of hi, we'll put system prompt here. And then the user has the task definition, right? This is like ChatGPT knows it's a poetry robot. You come in and ask for the poem. we could ask for 256 tokens, but I don't know, maybe 1,000 tokens is better for a poem. Temperature 1, let's do the temperature 1.5, 1.5. And that's seems good. And so we could run this, right? We would have to put a, if we want to do this, we would have to put an API key in. So I'll do that now. Okay, so I went and got my key. So I'm going to go over here to this key on the side, click the key, and then it'll have, actually it has secrets that you can use over and over again, but I'm going to add a new one just to show you how. I'll add OpenAI API key. The library will look for that for you. And then I'll just paste this in. No, alright, don't show it. Anyway, and then I'll click that to give it the access. So then I'm just going to hit play. Let's see, there's prompt down here, and then there's save to file. So now I'll need to write a saving to file function. Now I can kind of go back here and like reading and writing files in Python. Great. Okay. So I'm just going to go over here, paste this in. We've got our file. And, all right, so now I need a function that says def save to file, right? And I'm going to pass in language model, system, prompt, task definition, and results, right? Now, I've got that code here, so let's read it. File equals open example.txt. So we probably don't want to call it example.txt, but it's going to open it also for reading. So let's go back over here. I copied and pasted this as reading files in Python. We need to write files in Python, writing files in Python. Okay, example.txt w. So I'm going to copy that. Go back over here. No, that's not where I was. I was here. Paste it. Tab it over. Okay, cool. So now let's look at this. How do we want to save this? Well, what's the thing that's mostly going to be different? Language model, system prompt, and task definition, right? But also task definition could get long, so it might not be a good file name, right? So here's what we could do. We could say, okay, so the file name equals, and we want to maybe have like a timestamp. So I'm going to import date time. It's okay that like you don't know all of these things that you can import. It takes a while to learn them. So like if you're just like, what do I use to do this thing, to another engineer, they'll help you find this. Also ChatGPT can help. So I'm going to import datetime. File name equals datetime.datetime. Don't ask me why you have to do it twice. It's like a complicated story. And then you just do, or I think datetime.datetime.now. I think it's how you do this. So it'll give you a date stamp, which is unique, right? Especially because it takes a few seconds for each thing to happen, so they'll all be separated by a few seconds. So I can do this. I can say filename.txt. It would be probably good if I put them in a folder, right? And we don't have a computer up yet. Oh no, wait, now we're connecting. So we do have a computer up now. So we'll go ahead and we'll just put them. We'll put them in the folder we're in for this moment. So we'll do quotes around this, and then we'll put a plus sign. This is how we can kind of say, okay, right where we're, right in the folder that we're in right now, give me a date time, and then in the file, we don't want to write hello world, we want to write, let's see, we want to write, so file contents equals. Now, I'm going to use this thing called an F string. If you've never used one in Python, it's basically where you can kind of put variables in there. So I'm going to say language model colon, and then I'm just going to use braces, and I'm going to say language model. And now I'm going to say system prompt. System prompt. I'm going to say task definition. Task definition. Task definition. Great. And then results. This is a totally valid way to save logs, right? So, okay, so now I got file contents, and I need to put those contents in the file. And I want to say hello world. I want to say, you know, what happened here. Okay, so now we have everything, but these are down here, and this doesn't know about them. So I'm actually going to take this stuff, and I'm gonna take it out. And I'm going to put it into a new code block down here. Okay, so here's this. So I'm going to do play, and it's complaining about these spaces. Sometimes if you have extra spaces, it doesn't like that. So I'm going to hit play, and it's going to complain about how we don't have OpenAI. Great, so then I'm going to go ahead and I'm going to insert a code cell here, and I'm going to do %pip install OpenAI. I'm going to run it. Oh no, okay. Explanation point. It's different in different things. There we go. Pip install OpenAI. And I'm going to press this up arrow so that it goes all the way to the top. So we install OpenAI first, right? But we just did that here. And now we can go and try to rerun this code. So it's going to import it. And then it says, oh, no, we can't. Okay, so then I have to say, okay, import OS, OpenAI API key equals os.get in OpenAI API key. All right, cool. So then I'll say API key equals. I'll go. Okay, what's the problem? Yeah, I did. Try again. Print open or print that. Okay. Oh, it says none. All right. Okay. Oh. It's not this. Sorry. Okay. It's not os.getemp. It's this on Google Colab. I forget. Okay, cool. So that worked. All right. So you see this check mark where it says 0 seconds? It just took 0 seconds to set up these functions. Please don't use my API key. Okay. So now for this other function, and like, let's see, sorry. I actually don't need this code. So I'm just going to actually, let's see. Yep, I got all that stuff in there. So I'm going to delete this because it's sort of confusing. It looks like code, but it isn't. So I'm just deleting it. Now I have my code here. So now I'm going to run this, and it's going to complain. And it's going to say task definition is not defined. Oh, task is how I called it individually. Or here, actually, I'll just call it for task definition in task definitions. Okay, cool. And now it will run and save all the results to the folder, or it will try. All right, we can only concatenate string, not datetime dot datetime toString. Okay, so in the file saving thing, it says, okay, dot, and then file name equals file name dot strf time string from time. And so if I do that and I don't pass anything to it, it should just work. So I have to hit play again to make these be set up again. And then I hit play again and it complains and it says, oh, format. Okay, so let's see. strf time. You can go to strftime.org and it'll sort of show you, like, you know, the number. What I want is the Unix epoch time. Let's see. No, I want time zone microsecond as a decimal number. Alright, so what I want is the day of the month. And this is sort of a thing in Python that you'll need to know, is how does time work. Where do we go? Oh, it's up here. Sorry. Okay, so strf time, we need to give it a string. We want the day, or no, we want, let's do year first. So if we kind of go down here to the year, big year, nope, big year, then the month with 0 padding, so that it's 0, 9, not 9, so that they're all sort of the same length. Then the hour, or no, did we do the day? Yeah, we did the day. No, did we do the month? Yeah, that was the month. We didn't do the day. %d. And then we want to do the hour, padded, 0 padded, 24-hour hour. And then we want the minute. As a 0 padded number. And then we want the second. And you see how I am copying from the docs? I'm not bothering to memorize this. It's too much. Okay, and then we want the microsecond, because that'll give us a really, really unique number. We only need a unique file name. Alright, so let's run that and then see if this works. Great. Okay, it looks like it's working because it's taking a second to do. You see we've got results. And then, yeah, then we save to a file. So I'm going to hit refresh over here, and you can see it doesn't automatically refresh. You have to hit this refresh button. But you can see, if I do this over here, okay, results, none. Alright, so we're not getting results. Stop. Are we returning the response? In the prompt function, we're not returning the response. Return response dot choices dot at 0 dot messages dot content. Let's see what happens. Run it. So these are not correct. Let's hit refresh. Okay, it crashes. What's the deal? Not messages. Choices at 0 dot. Alright, let's just do that and then run it. So you see this iterative process is normal. I'm an expert engineer. It's been 45 minutes. All we're doing is 3 for loops. So it takes a second to do this stuff. Alright, is it working? Okay, wait. So choice dot message. Okay, stop. I want choice message dot content. Okay. Dot content. All right. Well, run, and then we'll do this. And then we'll hit refresh. Okay. Let's look at this. All right. So here we have, please write a nice poem. Please write a poem about snakes. Ta-da. And so we're just going to generate a lot of poems. Now, how many poems are we actually going to generate here? 4? No. 8 poems. 4 from GPT-5 and 4 from GPT-4. Now let's test 2. You are a poet influenced by Wordsworth, Dickens, and give me E. Cummings. Please write poems using these influences. Stop. Okay. So we'll have generated quite a few poems here. If I hit refresh, it's a lot. But let me run this again, and now we have 4 times 2, so that's 8, times 2, so that's 16. So you can see that we're climbing in complexity very quickly, right? And if we wanted to, for example, test each language model 3 to 5 times, you could see that pretty much in no time at all, like, we begin to watch cost climb. Let's see, that's not today. Today's the 11th, so wait for it. Today is the 11th. Okay, so we've got 10 requests today. How do I have 34 requests yesterday? That doesn't... Oh, no, I do. I know. Anyway, and so if we look, let's see. So cost will kind of go, let's see, 10 requests. How many tokens today? 64 tokens. Context tokens. Generated tokens, 334. Okay, the 8th of April. Anyway, okay. Sorry, I have to figure out which day I'm on. Okay, cool. So now we're up to 630 tokens, right? And so you can kind of see that it does produce quite a lot of data pretty quickly. So when we look at this, we're actually generating quite a few tokens when we test an evolved prompt. So we want to be really thoughtful about our task definitions. Usually we only want 20 or 30 task definitions for a benchmark. You could do hundreds. It's just that in order to test the benchmark, it'll cost quite a few dollars, right? So I'm just going to run these 16 against 3.5 turbo and 4 and show you kind of what we have here. I guess, I don't know how I generated that many tokens on that day, but laying graph. Oh, yeah. Okay. I see. It's just me doing this. When was that? Okay. Interesting. You can really dig in here. They didn't used to have quite as many of these. So I'll hit refresh and sort of see where we're at usage-wise. It won't tell you the cost that same day, but, you can kind of see, okay, 630 tokens, that's not so bad. It does go slow. The API is not lightning quick, right? And so let's look at some of these. You're a poem writing agent. Please write a nice poem. Please write a haiku about being a metaphor for death. Yeah. Okay, great. And then what's the issue here? It's probably complaining rate limiting. Generated invalid Unicode output. Okay. So I'll go ahead and say here, yeah, just right here, I'll say try, right? And I don't want it to break the whole thing. I don't want to have to rerun. So catch, or not catch, sorry, except error. Accept exception as E, and then print E, and then we just keep going. So I'm going to do this, and you will want to do something like that here. This basically just says, like, if you run into an error, don't stop and crash the whole program. Like, keep going. Like, just move on if you can. So, all right. So, this is how we run it. This is what we're going to do. You will need this code. You know, a really basic benchmarking to a really basic benchmark, right? This is not for running code. We haven't gotten into the depth of it. We'll get really into that on the first day of class. I just wanted to make sure you have the ability to get through all of this Python, and that you're set up and you've kind of got the concept of like how these numbers get really big when we want to test a lot of things. All right. Thanks for hanging out, watching. Hopefully this was helpful, and have a great day. Let me know if you have any questions.